years, 6 months. Just a coincidence though. So anyway, so back to the page script. So we have to work. So we have to work to survive, to earn money, to make our lives. But at the same time, the working is a burden. So it's kind of tough work. You know, it's tired. It makes us tired. So, but computers are great. Machines are great. So they'll never be tired. They are fast. They're never bored. They're fast. So working together with computers, we can be more productive, right? So when we work with machines, we can be more effective, more powerful. So this is great. The computers are a great companion, at least for us engineers. But so we have to beware of alpha syndrome. So have you ever heard of the alpha syndrome yet? Ever? So let me explain about the alpha syndrome. So alpha is a leader of a group of animals. So it's a leader. You know, alpha dog, alpha monkey, so alpha human or something like that. Alpha is a leader. So in a group of animals or the order or hierarchy, so they are alpha of each group. So imagine you have a pet dog, right? Like this one. This is my dog. So you pet it, you care of it, and then you work for it, and then you want to do everything you can do, right? So pets are very cute. But gradually, the dog assumes. So he or she or it is a leader of the family. So it starts to behave bad, like barking, biting, or something like that. So that is alpha syndrome. So now you understand the alpha syndrome is. And what is syndrome related to the computer science or programming? Just because machines can be alpha. They are efficient, they're smart, but they are not perfect. They don't have any intelligence as humans. So we have to tell them what to do in the form of programs. So we programmers direct computers how to work, right? So we have to care the computers. So they are far from perfect. We have to tell them line by line every corner of the behavior we expect from machines. So you have to work for them. You start to pay effort for them. So you start to think machines are alpha, right? So the people, programmers, engineers are willing, they're beginning to be willing to pay effort for computers. So you gradually became machine slaves. So this is the alpha syndrome in the programming field. So remember, you are the master of the computers, right? So you make machines to work, but you don't have to work for machines. You don't have to be slaves of machines. So let machines work for you. So this is the first design principle of Ruby language. So Ruby, what is Ruby? Ruby is an object-oriented programming language, and then with dynamic typing, right? So in the object-oriented programming with dynamic typing, the duck typing is the very intrinsic concept. So if it walks like a duck, quacks like a duck, it is a duck. This is the duck typing, duck principle. So we assume it is a duck. So quack like a duck, it's a duck. We assume it as a duck. So this is duck typing. No, this is duck typing. Or this is duck typing. So we don't care about the internal. This is essential essence of object-oriented programming. We do not classify. We do like animals, mammals, humans, or something like that. No. So do not check types. Just ask them what to do. So if they are duck, they walk, they quack. That's okay. We don't care about the inheritance. We don't care about the structure. We just care how it behaves. So we can ignore inside details. So we ask computers to dispatch, so we don't have to work. So let machines work for you to avoid alpha syndrome. Don't work too hard. Be lazy. This is very essential message in the design Ruby language. So have you ever heard the term dry? What dry is?
Don't repeat yourself.
Yeah, don't repeat yourself. This is very important principle in the design of Rails and the design of Ruby. So avoid duplication, avoid redundancy, avoid copy and paste. So by copying and paste, you can be very, very productive if your work is counted by lines. But it doesn't create any value. So because broaded code is not value, so it's bad. So dry is bad. So you spread bugs all over. You copy his code, and you copy his bugs as well. And because beside that, so we are lazy. We have to be lazy. So we are too lazy to maintain duplicates in your code. So you have to trim down your application. So in summary, the both two important concepts in the Ruby programming, the duck typing, dry, both rely on the spirit of laziness. Right? So you have to be lazy when you are a Ruby programmer. Right? So that reminds me the three virtues of a great programmer. So which came from the Larry Wall, who is the designer, creator of the Perl language, who is my hero. So he is my role model. Language designer, great presenter, and a great philosopher, like giving this kind of insights. So the three virtues of a great programmer: laziness, impatience, and hubris. Laziness means the quality that makes you go to great efforts to reduce overall energy expenditure. It makes you write labor-saving programs that other people will find useful and document what you wrote so you don't have to answer so many questions about it. That's laziness. Impatience. The anger you feel when the computer is being lazy. So we have to be lazy, but you have to get angry when the computers are lazy. So this makes you write programs that don't just react to your needs, but actually anticipate them, or at least pretend to. So this is the impatience. Hubris. The quality that makes you write and maintain programs that other people want to say bad things about. So the laziness, impatience, and hubris, they are three good values of a programmer. So So then the laziness, as the original author Laribo said, laziness is the most important virtue of all the three. So we should not work too hard. We have to be lazy. We have to enjoy what to do. Enjoy programming. This is a very important message from Ruby. So I started writing Ruby in 1993. We have been working so hard last 20 years to reduce our burden, to become more lazy. So 20 years later, so we have dominated the web. So we have so many programming languages out there: Java, PHP, Python, and some programming languages are more popular than Ruby. But so many startup companies, so many web services are using Ruby and Rails and some Sinatra, some Ruby-related technologies. So yeah, we can safely say we have dominated at least a part of the web. So thank you Rails and Ruby gems. But the prosperous must decay, so we cannot prosper forever. So think about the theory of evolution. We have to adapt the surrounding environment, or we will be extinct. So only the paranoid survives. So we have to do something every time to survive. So, for example, so we have some ranking named the TOB index, which is the programming language popularity index. So in 2009, so we had the Ruby was ranking at number 8, which is great. But last year we ranked in the number 18. So it goes down the 10 points. And then this year, the recent TOP index, which is announced every month. So the last TOP index ranked Ruby as a number 10. So it goes up and down. But we have to do everything to survive. So we have to do many things beyond Rails, like addressing microservices or front-end technology and research and building and embedded technology and many, many more. So for microservices like API building, so we have Sinatra or from Rails 5, it provides the Rails API since version 5. For front-end technology, so these days, Rails programmer spends more than half of their time to writing JavaScript, right? Yeah, but the people with the concept of the isomorphic programming, so bring Node.js to server side, so that they can write JavaScript for front end and JavaScript for back ends. That solves the language impedance, so you don't have to work the many programming languages, but JavaScript. The JavaScript is pretty good programming language with some corner cases. But for isomorphic programming, we have technology like Vault. Have you ever heard of the Vault framework? So Vault is the recent web application framework, so which is the back end is of course written in Ruby, and the front end is also written in Ruby through the Ruby to JavaScript transpiler named Opal. So you can write the back end and front end in Ruby with, or even you can share sometimes the MVC model in the back end and front end. So in some, the recent web frameworks, so you have the MVC model in back end, you have another the MVC model in the front end in the browser. So that is kind of too much complicated. So, but with technology like Vault allows you to share that kind of model in both sides in same language. So that is kind of the solution for dry in the backend and front end. I'm not sure both will be next Rails or something, but this kind of idea can be very good candidate of the future web technology. So we have other technology like a clear water, which is kind of like a default, but it is the plugin for Rails. So you can write down the front end, like the Rails front end, in Ruby instead of the, say, CoffeeScript or something like that. So this is, I'm not sure these specific two will be the future or not, but the concept in them can be very good potential. Research computing. In research computing, so Ruby is pretty weak. In university or in academia, so the Ruby is pretty weak, I admit. But the Python or Julia or R or MATLAB or some other programming language are pretty much popular in research computing. But at least popularity is formed from the many factors like libraries and the education and the community or relationship with the other members or something like that. But at least technically, I want to provide the ability to do the proper research computing or number crunching. So we recently sponsoring the project in Science Ruby, which allows Ruby to do the fast matrix calculation or the number crunching or something like that. Or embedded technology, like small devices or embedding in the application. So Ruby is pretty weak there as well. So we provide technology named mRuby, which is the embedded Ruby, which is the small alternative implementation of Ruby language. So you can embed mRuby in your application or in your systems, or you can run mRuby in a small computers, small embedding devices. For example, like a vending machine or internet router or the microsatellites can be run with the mRuby. At least we have some experiment with embedding these mRuby into these applications and these systems. So we have to do everything we can do to survive. So to help you avoid working too hard. So we, the core team, the Ruby developer, so work pretty hard to help you avoid working too hard, right? So to make injury framing. So to fulfill that kind of purpose, we have started working on Ruby 3 by experimenting ideas. So we have several ideas about the Ruby 3 to come, and we are experimenting these ideas. We do not have the specific one, but we have several ideas for each concept we want to accomplish in the Ruby 3. So we don't promise anything yet, but we want to address the man-machine collaboration and concurrency and performance. So we will improve the Ruby to be. We want Ruby to be improved in these things. For man-machine collaboration, like programming is man-machine collaboration. Usually, so the man asks programmers write programs and tell machines to do. But when we have errors, so the compiler complains usually. So errors is the communication from machines to programmers. So this two-way communication is mostly unemphasized. So recently we introduced the Jubin gem into Ruby 2.2, 2.3. So when you make the name error or you type wrong in the variable name or method name, so Ruby will suggest the candidates of the correct names in your program. So in that way, you can easily debug your program. That kind of the two-way communication can be key for your productivity. So for Ruby 3, we'd like to introduce some kind of soft typing. So the not gradual typing, which is the part of your program is typed, statically typed. The other part of the program is not typed. So by inferencing, so the compiler can fill the gap between untyped programs, that is gradual typing. But like the TypeScript for JavaScript, the Microsoft JavaScript dialect is an example of the gradual typing. But we are not going that way. So, or optional typing. So the gradual typing without inferencing is the optional typing. So we are taking that way. So the soft typing is the other way around. So type declaration are redundant for Ruby. So your program runs without any type declaration, type annotation. So I consider type declarations are redundant. So against the dry principle. So I don't want to write type annotations. So because one without them, so we don't need type declaration. So it's against dry. We are lazy. We have to be lazy. We are too lazy to maintain duplicates. So to solve that, soft typing is a kind of static typing everything and find contradiction. So like a global type inferencing. So it's a best effort type checker. So in some cases, so you cannot guess any type information. So in that case, Ruby just give up the type inferencing. So Ruby runs anyway. But if the compiler can find contradiction in your programs, so it can report your error. So your program has this and that contradiction with the types. So your program might have a bug or at least a logic contradiction. So it's based on backtyping and type inferencing. So this is very, very, very small example of type inferencing. So A equals to 1, so that indicates the variable A, type of the variable A should be integer. So this type method definition of foo indicates the argument x requires to have two int method. So with that information, so the calling foo with 1 is okay just because 1 has two int method. But calling foo with the argument of strings with error just because the string does not have two int method. So this is very simple and easily gets an inferable example. But if you do this kind of inferencing for globally in your applications, so that it can find the logic contradiction. So it doesn't have any type declaration, no type annotation, and then maintain per of databases. So you can access the ID, for example, the IDE or Eclipse JetSpring or something like that can access that database to use it as the source of the code completion or type inferencing or anything like that. And I'm not sure, but it may correct runtime info as an addition. So it's since the global inferencing may fail very easily, so we have to collect runtime information to the realistic type, the soft typing. And we are right now experimenting on it. Okay, the second part is concurrency. So computers 20 years ago, when I started designing Ruby, the most computers have only one CPU. So we don't have to care about the many cores. But now we have the days of multi-cores. So the computers we have dual core, quad core, and octa core, even for the smartphones. So we need to be concurrent. So the need for concurrency raising higher and higher in these days. But the many people complains about having GIL, which is the global interpreter lock. Ruby has something named the global interpreter lock, just because the Ruby virtual machine itself is not thread safe. The part of them are thread safe, but most of them are not. Just because writing thread safe virtual machine is pretty difficult. And then, or adding very fine grained lock can be solved the GIL problem, but it slows down the single threaded program lock, just because locking, unlocking, and locking, unlocking is a very huge cost. So this is kind of our compromise to be safe. We use the Ruby use native threads with GIL, but the Debian Rubinius does not have. So if you have a